In this video, I'll explain why I believe you will find FastAI to be both exciting and important. Our goal as data analysts and as data scientists is to make the organizations that we work for better, to use data to make operations and decisions better, faster, and cheaper. When Major League Baseball scouts started using data in their decision-making, they learned that college players were undervalued relative to high school players. This insight let them shift their efforts from lower value activities to higher value activities. In the 1980s, a lot of device-specific code for printers, modems, monitors, even databases was moved from applications into operating system drivers. It freed up more of the work of software developers to focus on higher level activities. Now, let's talk about FastAI's value proposition. To make state-of-the-art model performance with less code, faster and easier. Over the past decade, deep learning has established itself as the best way to work with image, text, and multimodal data. It's increasingly also a good choice for building predictive models on tabular data. But to achieve state-of-the-art performance, researchers and organizations that want to compete on the quality of their models have had to build increasingly complex models with more and more layers that require more data so that the signal doesn't get lost in the noise, and higher computational cost and processing time. Sometimes millions of dollars and millions of labeled data observations are required to deliver this level of performance. And few people have the skill to build and maintain these models. Transfer learning, which predates FastAI, has been a game changer in deep learning, since we're able to leverage existing deep learning architectures to build models that cost less in terms of computation and data requirements. Andrew Ng said that after supervised learning, transfer learning will be the next big driver of machine learning success. Now we're going to look at two examples of how FastAI lets us build models with less effort. First, the way FastAI's data loader classes are designed enforces best practices around the reporting of validation data instead of training data. I've personally seen again and again, not only in student work and student capstones, but also in business applications and research papers I've been asked to review, where results were reported only on badly overfit training data. So, because FastAI bakes in these best practices, it helps me make less costly errors. The second example is around how FastAI makes transfer learning simple. You choose your deep learning architecture and you make it an argument to your learner creation method. We can see there's a trade-off between accuracy and speed when building the model that we'll base our transfer learning on. You may, for example, decide to swap out ResNet 34 for the more accurate but slower to build ResNet 50. If you buy into this, the impact is profound. Since you can easily leverage hundreds of pre-built architectures, it means that the higher value work shifts from building out your deep learning architecture to focusing on your input layer and your output layer. So, as we go through Jeremy Howard's videos and notebooks over these next few months together, ask yourselves, did FastAI achieve its goal of letting me focus on higher value activities in my predictive model building efforts.